Hi everyone. This is an integrated science session, and we're doing general knowledge. Okay, so we will be looking at acid base and salt briefly, and if we have time, we shall be talking about energy transformation in physics as well. So let's have our heading. All right. So let's start with your acid base and salt. You've confirmed to me that you already had a brief discussion about that. And it looks like you have very limited information. So let's see. So when in exam, you may not get the question quite simple that define an acid. No, sometimes they specify define Arrhenius acids. So what's that? So three scientists propose a definition of acids. Okay, and in exam you might be asked to define according to a specific scientist. So that's what it is. So what are the three sciences that produce the definition of acids? So let's run through them. Yes, class. I thought I've taught you this. Mm-hmm.
Bronsted-Lowry.
Okay, Bronsted Lowry. Who else again? Hmm? Who else again? It's called Arrhenius. Bronsted Lowry. Who else again? I'm not spelling it well. Bronsted. Who else again? Hmm? Well, by the way, I hope you are writing.
Yes, sir.
The next person is Lewis. Let's run through quickly. So Arrhenius said an acid is a substance that produces um, hydrogen or hydrozonium ions. I don't have space, so let's just say in an aqueous solution. In an aqueous. Have I spelled it well? Me as a teacher, I'm even confused. No, I'm coming. It's funny, right? Yeah, in an aqueous solution. Yeah, it's a problem. Oh. I'm asking myself, is aqueous spelled correctly? Anyway, yeah, so yeah, an acid is a substance that produces hydrogen ions, right? Or hydrozonium ions in an aqueous solution. So that's what Arena said. Guys, can we continue? So this is hydrogen ion. So I was talking about that in preparation of gases, right? There's a chemical formula for hydrozonium ion. I hope Mr. Gilbert told you, right? Hi.
Hi.
If you not respond to me, I'll close the class. Oh. I can't get up very early and then be talking to myself. My neighbors might think I'm mad. Yeah. They'll call the police that someone is just yelling, making noise here and there at this early hour. We are all asleep. Anyway, so that is it. So yeah, there's hydrogen ions. So when you have a reaction, you know chemical equation, right? Normally, what is after the arrow is called what? It start with P. You know chemical equations is something plus something, right?
Yes.
Then at the product side, oh my laptop, come on, this charger is too strong. I'm coming. How do I collapse this? Yeah, collapse. My friend, just go. Yeah, chemical equations is typically something plus what? Something. Yielding. Now, what is after the arrow are called what?
Products.
Product. So, in any chemical equation, if in your product you have H plus or you have H3O positive, then the reactant, what's are the reactant? That element that that element that produce those product, that, did I say element? That compound. Okay, that compound is acidic. That's all. Is it clear?
Yes, sir.
So normally there's a question in exam, define arenos acids and give two examples. So let me give you the two examples. So when you meet it in exam, right? So one acid we can use it HCl. And you know the name from laboratory preparation of gases. I'll not see it here. You know the name.
Yes.
Now, in water, watch. So in water, so there's my water here. H2O, you know, right? It's water. In water, it dissociates completely to form H plus what? Cl minus. It splits. So do you see H plus? That means this compound is what? An acid. Or you don't see H plus. You be quiet. Can I move on?
Yes, sir.
Or you can rewrite it as this HCl plus water. Plus water. Sorry, I'm speeding up and you said you've done it. So plus water. Now, the one hydrogen element will come and react with this, right? How many?
Yeah.
Let me look at the attendance. Madam Precious, if it has changed, you update my list for me.
Yes, sir.
So one hydrogen will come and join with water here. What will happen? It's two over there. It will be H how many? 3O. Now this is a radical, right? And I said radical in laboratory preparation of gases. It's a radical. When you see H3O, their charges were positive. You see? So what will be left? You have removed the H. You are left with what? Cl or minus. Do you see H3O plus? Yep. So that means that that medium, that ACl, that compound is what? Acidic. So this is an arenous acid. So don't write the two examples in exam. If you are being asked, you just write one. But I'm just telling you, you can choose any of these options, right?
Yes,
sir.
Yes. Yeah, so good. You are following. Now let's look at another acid. So we can have nitric acid. Would it be complicated for my kid? Nope. A2SO4. Right? A3SO4. So plus let me see. So plus water. What are we getting?
Yeah.
Okay, you finish up. You finish up.
Oh.
Are you done? So one hydrogen will come and react with this, guys, and it's going to be what? Patience. No, Cecilia. Cecilia, it's not rocket science. One hydrogen is coming to react with E2S, so it's come to join that. So yes, it's two there, my dear. How many would it be now?
H3O.
Excellent. Take 3O. Then it's a radical. The sign is positive. How many H is left here, guys? How many H is left? One. So that will be H what?
SO4.
SO4. This thing is simple. By the way, it's a radical, okay? The sign is minus. Can I move on?
Yes, sir.
Yeah.
A question.
Okay.
Let me finish
Why
my
not-
first. Let me finish my first. Yeah. So, you see A3O, right? Positive. So it's acidic. It's acidic. That it should tell you that no, then that solution, that compound is what an acid, okay? A2SO4 is an acid. My dear, go on. I'm listening to your question.
Sir, please, why didn't the both hydrogen elements move to
Mhm.
come? Why is it H3O not H4?
No. Okay, so this one, I'm applying a little bit of as advanced knowledge. Here is the thing. I know A2SO4 is acidic. Do you understand?
Yeah.
It's acidic. You see, many of the chemicals we are using, we have used them it's used in a laboratory by chemists, right? And it's found that it's in fact a strong acid. It's a strong acid. So your chemical equations should reflect that because chemical equations are established out from preparations that are done in the lab. Do you understand? So it's acidic. So if you see A2SO4, it should be one hydrogen reacting to, okay. Trust me, I'll not give you anything weird like this anymore. Okay. Yeah, most of them it's quite simple. But A2SO4 is an acid, so just know. Yeah. So that's why we chose to use just one hydrogen. There's no radical like H4O. There's none like that.
Yes, sir.
We don't have any radical. So you see, the radical, but guys, you see, the radicals I gave you back then, you see that I'm using the same radicals. So in that lesson, the radicals I gave you, they are the radicals so meaning we have like very few radicals. You should know A3O was part, and today I'm bringing it here. So you can learn them.
Okay, sir.
Can I move on?
Yes, sir.
Mhm. Where am I? Yeah, so don't you let me add some more, right? Because sometimes they can say 3 examples. So let's do HNO3. Hey, but you don't have time to. What do we do? Should I skip? Don't
My
have time
examples.
to. Okay, you let me add one more. You see, you don't have time. That's the point. The laptop too is misbehaving, huh? I'm coming, guys. I need to make time and go to the mall to change the cord, the laptop charger cord. Yeah, HNO3, guys. Right?
Yes.
Plus, yeah, so, but by the way, hold on. So that A2SO4, can you rewrite it this way, like this? Can you do it? Can you tell me? Can you rewrite it that way for me? Do it and tell me your result.
Okay.
Yeah. So in water. So in exam, when you are writing the equation, you can choose which one you want to use.
SO4 minus. It's H minus. SO4 minus. It's last. It's the same case. Just we shouldn't need to learn English. Okay, so we are done.
Okay. So what are you getting over there? This one, if you are smart, you get it. Who tell me?
H.
You might have to balance also. Be smart. It's H plus, right? Plus what? SO4 minus. But if you are smart, SO4 there is 2 minus. If you watch, there are 2 moles of the hydrogen. You balance. Yes. The hydrogens were 2.
HS O4 minus plus H3O.
Come again. I couldn't get that. Come again.
HS O4, which is a minus, plus H3O.
No, you don't get that's already done. Okay, you study the first example I gave. You said acids produce H plus or H3 minus. Acid produce H plus or H3 minus. That's what we said, right? So in every single example I give you, I try to put it in each form, like make a yield H plus or A3 minus. So in exam, you choose which, you don't have to write it to choose one. So we are done with what Victoria, whoever was talking, said. We are done with that. I think it was Cecilia. Now, I want you to make a yield H plus. So H2SO4 in water, the water is written on top of the arrow, gives H plus. Do you understand? Then mind you, the hydrogens are 2, so 2, right? Plus SO4 2 minus. Yeah. The 2 minus represent the charge. SO4 is a radical. Go back to your notes. It's the SO4, their charge is what 2 minus all the time, right?
Yes, sir.
My dear, have I answered your question? Did she say no or yes? Did she say no or yes?
Yes.
Okay. HNO3 is an acid. It's called nitric acid or triazonitrate 5. Refer to the page. When you go to the page, laboratory preparation of gases, this is discussed extensively. So plus, so in water, right? What will happen? Tell me. This is not hard. I want, no, not patience. Cecilia, will you give it a try? Looks like I'm worrying you today. No, Benes, go on. Say it for money. Say the answer first.
How much?
And so without the amount, you see women. Let me choose a guy. Michael, tell me,
H3O plus.
H3O plus, yeah. Then plus what? What is left? Oh, this structure. Plus what? So you see, he has moved the H, so he's left with what? Oh, come on. He's left with what? NO3. You see, and it's a radical. Their charge is minus. Go back to your note on radicals. Any question, guys? Now, can you represent it with, let it yield just H plus and let me see. So in water, so this one, it just splits.
H plus.
Mhm.
H plus.
The charge is there, at least you should know minus. That's all. Look, the other acids, go and try them. H2PO4. It's called phosphoric acid. Go and try it. Oh, you don't have time. It looks like I'm giving you too many examples.
Yes. So the example is what?
It's okay, all right. But there's another one, oh, ethanoic acid. You let me do this for you. Let me do it for you, okay. In water, it will give you ethanol. And then what? H plus. Let me stop and continue. That CH3COO minus is called ethanol. Okay.
And the OO is what?
I said CH3COO minus is ethanol. You asked me and the O is what? Why is it standing on its own? Are you done? This ethanoic acid. And this ethanol. Can I move on?
Yes, sir.
All right. Let's look at Bronsted-Lowry definition of an acid. So that's where your definition comes in. That's where your definition comes in. What did you say?
Acid is a proton.
Yeah, so an acid is a proton donor. So in exam, if they say define acid, just like that, without saying according to this or that, then you can say, oh, an acid is a proton donor. No, you should say according to Bronsted-Lowry, an acid is a proton donor.
Yes, sir.
Yeah, you specify. So let's give other examples. Do you know one interesting thing? I want you to pay attention. I don't want you to confuse this. Now, when is Bronsted-Lowry and you have to give an example and choose this. Choose this. Please don't just pay attention. Choose this. You know, Arenos is flexible, but Bronsted, I want you to pay attention. Choose this kind of example. So you see HCl, water, right? Because HCl is an acid. Proton in integrated science or chemistry means H hydrogen, right? So now, because HCl is an acid C, it donates one hydrogen to water, and that's how I can get H3O. But the idea is it donates a proton. So choose that one. I'm marking another one for you. So here to choose it. So choose those ones that form the H3O. The point is not about the H3O form, all right? The point is about H2SO4, that acid donating a proton. So I believe you are writing that under Bronsted-Lowry, right? Oh, guys,
Yes, sir.
you understand everything I'm saying.
Yes, sir.
So I've marked another one for you.
So you should write it under Bronsted.
Yeah, of course, right? Because you can see that HNO3, because it's an acid, is donating a proton. Let me reduce the size for you. It's donating a proton to water, right? I'm gonna ask you a question. You'll finish. I don't want questions. Yeah, I'm here, guys. Okay. This is my question. I'm come to mark something for you. Should we write it as an example under Bronsted-Lowry? I'm come to mark something for you. This one. Should we write it?
Yes, sir.
Okay. We should write it. Who taught you? Not me. Don't mention my name. Who taught you? Should we write? Do you see donating a proton? Be careful with your examples. You said that according to Brunson Lorian, acid is a proton donor. So your example should show. Do you see it donating a proton? It's an acid, but it's not donating a proton. So it's not a good example. Choose examples that you see proton donation. You get it?
Yes, sir.
So the one above is what you should choose because you see the acid is there, water is there, and you see to donate proton to water, and that's what is giving H3O. Please, you get it.
Yes, sir.
So should we choose this one? Ethanoic acid. Can we choose? No, no, I'm not confident about it. You can't choose it. No. Right? So the only example, if you want to use CA3COOH, then it must go this way with water, right? It must go like that so that you can have hydrogen. You get it? CA3CO is an acid, so it will donate the proton hydrogen. So that side will be H what 3O positive. And what would you be left with on the acid? I think I'm speeding up for you so you don't get it. What are you getting?
Ethanoic acid.
No. Oh, come on, guys. You have C3COOH as an acid reacting with water. And we are saying that C3COOH has or will donate a proton. It has donated a proton to A2O and we have gotten A3O now. What's the left, Cecilia?
Water. CO.
Cecilia, what are you getting? I believe you can answer. What are you getting? I don't need a name. Just call it out for me. All right.
O2 plus O10. I think you do it.
Right. I'm repeating one more time. I have an acid. Do you see my screen?
Yes.
It's very clear. Madam Precious, you stop giving me videos. Is she in the room?
Yes, sir.
Okay. You have an acid. It's reacting with water. Now, Brunson said an acid is a proton donor. And your example should reflect so. And I'm saying that, yeah, it's a proton. What do you understand by donor? You give. So this acid is giving its proton to water. It's an acid. And in this reaction, it will give it proton to water. If you are giving me proton, I'm going to get A3O. I'm 2. Now you're giving me one more. So 3, A3O positive. What are you left with now in the reaction equation? What are you left with? That other person, countering what you are saying, you have to knock him or her. Is he a 3COO? Yeah, and the charge is negative. See, when you are being asked to define an acid according to whoever, and you are being asked to give an example, your example should reflect the definition. So if you are saying it's a proton donor, it must show. That's why check HCl. That's why this one HCl, we are choosing to go for the second one. So HCl, we are choosing to go for this one where it will be reacting with water and it will flexibly donate a proton to water, right? It's an acid. It donates a proton to water, become A3O, right? Positive, right? What are you left with? Cl, and the charge for chlorine is negative. People, I don't think I should continue. Am I speeding? Yeah, kind of, but is it complicated? You know mind me. Is it complicated? Hmm? Hello. Abba. Are they in a room at all? Or they went off? Hello? Hello? Think there's connection problem. So let's look at Lewis. The time is almost up. So, well, Lewis, you are not really bothered like that in exam, but you should know their definition. But those offering chemistry, you'll be asked for more, right? So, a Lewis acid is a substance that can accept a pair of electrons. Oops. A Lewis acid is a substance that accepts lone pair electrons to form a coordinate covalent bond. Yeah. Just know the definition, that's all. I'll not bother you much. Come again?
Please, I'm not seeing what they're writing.
Ah, you are blind. It's there. Or everyone can see, then you're all blind. Is it working?
Yes. So your writing is not good. Hard.
Let me see. Is it working?
Substance
That accepts lonely lone pair electrons to form a coordinate covalent.
So your writing is nice.
Thank you.
It's horrible.
I know she's being sarcastic, right? And that's not how I write, by the way. I'm using a digital pencil and it's just weird.
Okay.
So substance that accept lone pair electrons to form a coordinate covalent bond. Yeah. Yeah. Can we move on? Going. Hey, you guys are still not done. You have a lot to do. Keep writing it.
I'm waiting for you.
Oh, really?
So we are done writing.
Okay.
Yes.
Now,
Thank you. Are you writing?
now, what are strong acids? were you thought of that too?
Yes, sir.
You were taught.
You were taught. No. Answer that question. Answer that question. They are strong.
Strong acids and weak acids.
He said he has taught us. Say you he has taught you and say.
So strong acids are acids that dissociate completely in aqueous solution to produce.
Yes. What did you say?
Should I go on?
Yes, sir.
They are acids that dissociate or break down,
Yeah.
dissociate completely in aqueous solutions to produce, right? Hydrogen ions or hydrozonium ions. Hydrogen or hydrozonium ions. Hydrozonium. X, all right.
Okay.
Ions. Then weak acids copy the same thing. They are acids that dissociate, but say partially. Partially.
Okay.
So they are acids that dissociate partially in aqueous solution to produce. I promise to close you at 12:20. So we have 3 minutes more. They are acids that dissociate partially in aqueous solution to produce hydrogen or hydrozonium ions. Let's look at some examples of these. Let me know when you have landed.
If you are there. Say you are not there.
Okay. So, can we move on? So, for strong acids, examples are HCl, H2SO4. I hope you know how to write them.
Yes, sir.
HCl, H2SO4, HNO3, HNO3, H2PO4.
H2PO4.
Yeah, phosphoric acid. They are all strong acids. If you don't handle them with care, you burn yourself. Can we move on? Can we move on?
Yes, sir.
Then the weak acids, we have ethanoic acid. Those organic acids, ethanoic acids. We have butanoic acid. We'll look at them. So I said basically they are the organic acids. When you go to something is burning. Come in. Anyway, yeah, butanoic acid. You're laughing at me. Ascorbic acid. They are a lot. If you take note of this word, organic acids, it will help you a long way. It will make you get a lot of options. Malic acid. I think someone was saying something. What do you have to say? Tell me. Citric acid, etc., etc. Shall we?
Yeah.
Yeah. Unfortunately, I have to pause. So we'll have a discussion again, guys. Goodbye.
Yes, sir.
That is one.